Hello and welcome to Quadratic 7.1, solving quadratic equations with complex solutions. Okay, so we kind of did this the last lesson, yeah, because we solved quadratic equations using quad formula and we got complex solutions. We got answers that had I in them. Yeah, so this is kind of like the same exact type of situation that we had the last lesson, except we're not going to use quad formula to get our answers. We're going to use complete the square, yeah, which is something that we learned back in first quarter. All right, so please don't get the temptation to use quad formula to get your answer. Please stick to complete the square because we want to make sure this does two things. It shows you that you can have multiple techniques to get the answer to a quadratic equation, and it's gonna refresh your memory on complete the square, which you might have already forgotten. Yeah, because it's been a while since we've seen it, right? It's been at least 3 weeks maybe. So we want to make sure it's still in your brain. All right, so let's refresh on how to do complete the square. Okay, so let me write out the problem down below because I need to manipulate it. So x squared plus 4x plus 11 equals 0. Okay, so to complete the square, we want to grab our middle term, 4. Okay, and we want to cut it in half. And then after we cut it in half, we're going to square it. Okay, and the result of that process of cutting the middle number in half and then squaring it tells us the number that should be sitting right next to the 4x, which in this case is a 11. But in our situation, we need to have a 4 in that spot. And unfortunately, 11 is not known as 4. So we need to politely tell 11 to beat it, to get out of the way. Okay, so I'm going to get 11 to beat it by subtracting 11 on both sides. And then I'm going to make space. Oops, that's the wrong color. I wanted blue. It's going to leave a space for the 4 to go and sit right next to the 4x. Yeah, because the 11 canceled out. And now the 4 can go right into that spot. So here's where you got to be really careful. And I kind of mentioned this the last time I talked about this process also. Yeah, we know we want to have a 4 right there in that spot. But you can't just put positive 4 on the left side and not put positive 4 on the right side, because that's one of the basic rules of manipulating equations. Whatever you do on one side, you have to do on the other. And if you don't put plus 4 on the other side, then it's game over. You broke a major rule, and your answer is guaranteed wrong. Okay? So then on the left side, you're going to factor it. So what? Two numbers make 4 when you multiply and 4 when you add. And hopefully when you realize that answer to that question, you're going to say, oh, 2 does that trick. So 2 times 2 is 4. 2 plus 2 is 4. Yeah? So that's going to be how you factor the left side. And if you're doing this correct, here's what you're going to notice. You're going to notice that your two parentheses are exactly the same. And if your two parentheses are exactly the same, you're on the right track. If your two parentheses are not the same, you're not on the right track. Okay? So left side we get the two exact parentheses. The right side we're going to get negative 7. Okay, so let's clean up that left side. We're going to write x plus 2, just one of them. We're not going to write 2 anymore. We're just going to write one of them. We're going to put it squared equals negative 7. Okay, so here's what you want to remember about complete the square. That his role, his job in life is to make vertex form. Okay, that's his one role. That's his one mission. He has one job, and his job is to make vertex form. Okay, so right now we don't have vertex form because the negative 7 is supposed to be my k value. But usually the k value doesn't sit on the other side of an equal sign. So how do I get this negative 7 to go back on the left? Well, you're gonna add 7 on both sides. And when you do that, vertex form now makes its appearance. Okay, so we're going to have x plus 2 quantity squared plus 7 equals 0. Okay, and this is called vertex form. And what you want to get into the habit of doing is every single time you do the process called complete the square, you want to make sure vertex form is on your paper. Because if vertex form is on your paper, then you didn't do complete the square. Okay? And eventually you're going to say to me, you're going to say, why did you make us do all that extra work? Yeah, and I'm going to respond, well, because if sometimes you do complete the square and you stop at this step, And other times you do complete the square and you stop at this next step, you're going to get confused because you're going to say, when do I stop? Do I stop here? Do I stop there? Right? So the way I fix that is when you do complete the square, always go to vertex form. Never stop halfway, never stop 3/4 of the way. Always do all the way to the end. It's like baseball coaches say, right? Right? When you hit the ball, you make contact with the ball, you run to first. You don't stop halfway because you know you're going to get out. You run hard till you reach first. Yeah? And when you get there, then you can start slowing down. Just like this. We don't stop doing complete the square until we get to vertex form. We don't stop any sooner than that. We stop when we get there. Okay? So how does that help us solve for this problem? Well, we're going to continue in stage 2 of this process. So stage 1 was to complete the square so that we get vertex form. Okay? Stage 2 is going to be grab vertex form, so x plus 2 squared plus 7 equals 0. So grab vertex form and solve. So when we solve, we're going to get rid of the 7, we're going to get rid of the power of 2, and we're going to get rid of the 2 in the parentheses. So we're going to run a process that I refer to as reverse PEMDAS. Okay, you're not going to see that in any handout or anywhere in any textbook because I'm pretty sure I made up this term, or maybe other people did too, but I don't see it anywhere on the internet that I've seen. Okay, so we're going to call this reverse PEMDAS. Where when we solve for x, we're going to get rid of the numbers in reverse order compared to regular PEMDAS. So usually in PEMDAS, we do parentheses, exponents first, right? And then we do multiply, divide, then add, subtract, right? But in reverse PEMDAS, we're going to get rid of the add, subtract at the very beginning. Okay, so we're going to get rid of that 7. So how do we get rid of this 7? Well, how do we send it to the other side? We're going to subtract 7. And here's where kids, they tell me, oh my goodness, we had that. We had it earlier on that left side, but you made us continue all the way till we got vertex form. We had that. We didn't need to go all the way to vertex form. We could have stopped right there. But my response is, well, if you stop here sometimes and you don't stop here other times, you're going to get confused because you're going to say to yourself, oh, when do I stop here? When do I stop there? Right? Because you're going to have 2 different situations where you can stop here or you can stop there. And you're going to get confused. I guarantee you're going to have that confusion. Yeah, this technique is you just always go to vertex form no matter what. And if you got to do one extra step, big deal. Right? So what's so difficult about subtracting 7 and making you go back to the other side? Right? That's not a big deal. Yeah, you're going to cause yourself way more stress if sometimes you stop here and sometimes you stop at vertex form. That's way more stressful because you're going to have to figure out when you can stop at each route. Okay, so let's get rid of the power of 2 next. And to do that, we're going to square root both sides. And when I square root both sides, hopefully you remember that plus or minus is going to also be right next to that square root symbol. And notice, ooh, what else do we have in the square root symbol? We have a negative sign there. So we're going to start taking advantage of our imaginary number calculations that we started to do this quarter. Okay, so left side we're going to take it slow. Left side we're just going to get x plus 2. Right side we're going to get plus or minus. And then we're going to simplify my radical. We're going to go negative sign is known as II. And the 7, yeah, that can't be broken up anymore. So we're just going to leave it as 7. We're going to circle things that match. So my i's match. My 7's don't match because there's only one of them. So I get x plus 2 equals plus or minus I root 7. Okay, and our very last step is to get rid of the positive 2. So we're going to subtract 2 on both sides. Remember, my answer is going to be a complex number. So the rule for complex number is real numbers in the front, so that's my negative 2. Imaginary numbers in the back, so that's my I root 7. Okay, so make sure you write it in the correct order. So my final answer is right here. Okay, all right, next problem. Letter B. Okay, so my middle number is a negative 6 this time, so I'm going to run my process, cut it in half. I get negative 3. Then square it. I get 9. So 9 should be the number sitting right next to negative 6. but unfortunately the 25 is. So we need to tell we need to tell 25 to beat it. Okay, so how do we tell him to beat it? Well, subtract 25 both sides, and that'll effectively make him beat it. So subtract 25 on both sides, and coincidentally, yeah, this process that we're running on this left side, right, of the paper of this software is called complete the square, right? We're doing the process called complete the square right now. Okay, so that's stage 1, remember? Stage 1 is going to be complete the square. Stage 2 is reverse PEMDAS. Okay, so what number do we want to have sitting right next to -6? Well, we want to have a positive 9 sitting right in that spot. So put +9 on both sides. And now let's factor this left side. So what two numbers make 9 when I multiply and -6 when I add? And remember now, when you do this and you write your parentheses, you want to have the exact same parentheses appear twice. Because if you don't have that, then you're not going to make vertex form appear in your paper, because vertex form is going to be that exact same parentheses squared. So that's why when you factor it, you have to have the exact same parentheses appear twice. So -3 makes 9 when I multiply, yes. -3 make -6 when you add. Okay, so right side you're going to get -16. So let's clean up that left side. We're going to write x minus 3 squared, because that's part of the vertex form, right? What it looks like, equals -16. And should we stop here? No, because we're not at vertex form yet. So let's make this 16 go on the left side. So add 16 on both sides. And we get x minus 3 quantity squared plus 16 equals 0. Okay, so now we have the permission to stop, right? Because we got the vertex form. So this is vertex form. Complete the square. He has done his mission, or he has accomplished his mission. So he can go home and have some relaxation. Yeah, he can just go home and cruise. All right, so stage 2. Yeah, reverse PEMDAS. Is that crew ready to go? Is that crew ready to do its thing? Well, first thing we need to do is we need to hand off the baton to the reverse PEMDAS crew, right? And we're going to tell them, take over, solve for x. And their first thing is going to be, okay, let's do reverse of what we normally would do, and let's get rid of that 16 first. So we're going to subtract 16 on both sides. And I know you're going to complain, you're going to go, oh my goodness, we just had that. We had that on the previous stage. We had that right before we got the vertex form. And I'm not going to say it because I already said it like 5 million times already, so I'm not going to say it. Okay? Trust me, I've been doing this a long time. I've seen kids make a lot of mistakes, get confused about a lot of things, and they eventually say, yep, I should have just listened to you because you tell us mistakes and things that confuse kids based on your experience, not because you just want us to do more work. Yeah? And I go, yeah, I know, but you got to learn the hard way sometimes. Okay, so let's get rid of that 2, that power of 2. So we're going to square root both sides. And, ooh, look, we put a negative sign inside that square root, so we're going to get an imaginary number. And don't forget that plus minus sign also. So left side we get x minus 3. Right side we get, let's simplify this. So negative sign turns into I. 16 turns into 4 times 4. Let's get the red pen out so we can circle things that match. So I match, 4 matches. So x minus 3 equals plus minus 4i. Okay, so one last step. So let's get rid of that -3. So add 3 both sides. And when kids make a mistake here, they call this 7i. Yeah, because they forgot that these guys are not like terms. And don't forget, real number in the front, imaginary number in the back, because that's the complex number. That's how you write complex numbers. Yeah, but when kids, they make a mistake, they go, oh, plus or minus 4i plus 3. Yeah, they write the reverse order. So make sure you don't put the wrong order. Okay? All right, next problem. Letter C, I'm assuming. Oh, maybe not. What else is there? Okay, so let's see. What's my next problem? Okay, they're going to start making they're going to make things more complicated. They're going to put a number in front of x squared. And we're still going to complete the square of the process, but we're gonna deal with a different starting point. Okay, well, there's going to be fractions in front of x squared also sometimes, so that's going to make a different route as well. Okay, so let's see what we have here. So we got 2x squared plus 16x plus 40. So normally my first step would be grab 16, cut it in half, square it, but I'm not going to do that. Okay, so when you do this process called complete the square, you don't get the green light to start if there's a number in front of x squared. Okay, so do not start complete the square if you have a number in front of x squared. And you're going to say, but normally don't we have a number in front of x squared? And yeah, 1 doesn't count. Okay, so don't ask that question. Okay, but yeah, if you see a number that's not 1 in front of the x squared, you do not have green light go as far as starting complete the square. So you got to get rid of that 2. And the only way to get rid of the 2 is to divide by 2. And you can't just divide him by 2. You got to divide everybody by 2. Don't leave anybody out. That's not nice. Okay, include everybody with divide by 2. Okay, do not leave anybody out. So my brand new equation becomes x squared plus 8x plus 20 equals 0. Okay, so now we have green light go. Now we can cut the 8 in half. We get 4. Square it. We get 16. Okay, so 16 should be the number sitting right next to the 8x, not 20. So we need to politely tell 20 to beat it, to go on the other side. Okay, just make sure you're polite about it. Don't be mean about it. Okay, so x squared plus 8x equals negative 20. Okay, so now we can put the 16 in that spot because that's the number that should be sitting right next to 8x, not positive 20. Okay, so let's factor that left side. And since I know I'm kind of running short on space on the bottom, I'm going to just write the single parentheses with the square. Okay, because we know we're supposed to have the same exact parentheses twice. Yeah. So what number makes 16 when I multiply and 8 when I add? And hopefully you say positive 4. Okay, so now let's get this negative 4 on the left side. And we can't really say this is vertex form this time though, because when I get this end result right here, which is x plus 4 squared plus 4. Okay, so this is not considered vertex form of my original problem. Yeah, but it is vertex form in the sense of the appearance as far as when we know complete the square, the process is done. So we can't really call this the vertex form of this problem. But as far as the end result, the goal line of complete the square, we're at the goal line. Yeah, we're done. Yeah, this is where we're normally supposed to end. And we're going to hand off that baton to my reverse PEMDAS crew, and they're going to take over. Okay, so that's, notice I didn't write vertex form because this is not vertex form of my original problem. Okay, so let's hand that baton off. So x plus 4 quantity squared or plus 4 equals 0. And let's solve for x. So let's move that 4 back on the other side, and you're gonna complain, and eventually I just don't hear it because eventually you realize, yep, you were right. We shouldn't have argued with that to you. And I go, yeah, I know. Okay, so we get this. Then we're gonna get rid of the square. We're gonna square root both sides and put the plus minus. And notice we have a negative sign inside your square root, so we're going to have an I make an appearance as well. So left side is x plus 4. Right side is plus or minus square root of I and 2. We get the red pen. We circle things that match. So I match. 2 matches. Okay. Oh, my pen is not working again. Okay, there we go. All right, so we get x plus 4 equals plus or minus 2i. Okay, so subtract 4 both sides. and we get x equals -4 plus or minus 2i. Okay, and there's your answer. All right, so let's go on to the next problem. Okay, come on, let's move. Okay, there we go. Okay, so once again, we can't officially start complete the square yet because we have a 4 in front of the x squared, so we got to deal with that. Right? Once we deal with that 4 in front of the x squared, we can start. But if we don't see that, right, and if we don't have that situation where the 4 is not there or is there, then we can't start it yet. Okay. So how do we get rid of that 4? Well, we divide everybody by 4. Okay, and just remember, divide everybody by 4. Don't leave anybody out. If you do, that's not nice. Okay, so we get x squared minus 6x minus 3 equals 0. Okay, so now we can officially start complete the square. We grab our middle number, -6, we cut it in half, and then we square it. So -3 times -3, and we get 9. So 9 should be the number sitting right next to -6, not -3. So we're going to politely tell -3 to beat it. So add 3 both sides. And we're going to get x squared minus 6x equals 3. Okay? And we're going to put that 9 right next to the -6x and on both sides. Okay, factor the left side, and I'm going to save some space because I know I'm supposed to have the exact same parentheses written twice. Usually I write the 2 parentheses 2 times, but I'm kind of running short on space on the bottom. So I'm just going to write it once. So -3 makes 9 when I multiply. -3 makes -6 when I add. Okay, so we're not officially done yet because we're not at the form, what we normally call vertex form. We're not going to call it vertex form this time because, yeah, we had to divide by 4. And when we did that, it kind of messes things up. So we can't officially call this vertex form for this problem. Okay? So we're going to subtract 12 on both sides, and we're going to get x minus 3 quantity squared minus 12 equals 0. So now that officially is the end of complete the square. They hand off the baton to the reverse PEMDAS crew, and they are going to take over and solve for x. Well, my pen is kind of going nuts. I think my computer is kind of lagging. So hopefully this video will make it to the end, and it won't have too much more problems. I think it's going to have some problems though. So my writing might get a little sloppy. I'm sorry. So x minus 3, and you're probably saying, start to get a little sloppy. It's been sloppy for a long time already. I know, yeah, sorry, my handwriting is bad. Okay, so let's just make the best of it though. Oh, this is getting kind of bad. Sorry about that. Alright, so let's get rid of the -12. So we're going to add 12 both sides. Yeah, it's getting bad. Sorry about that. You're going to see some numbers that are going to not look like nice things at all. So I'm going to try to fix it up when I can. But my computer is not going to play nicely. Yeah, it's going to do its own thing. Yeah, it's gonna connect things that are not supposed to be connected or erase things that are not supposed to be erased. And I'm super sorry about that. I'll try to make it nice, but no promises. Okay, so we got x minus 3 squared equals 12. Whoa, okay, it added an extra line to my equal sign. That's not good. I gotta erase that. Okay, then I'm gonna get rid of the square. So I'm gonna square root both sides. And don't forget the plus minus when I do that. And ooh, this time I don't have a negative sign inside my radical symbol. So I'm not gonna get an imaginary number in this problem. So x minus 3 equals plus minus, and when I break up the 12, it's known as 2 times 2 times 3. Ooh, okay, that looks like a -3. I need to get rid of that. That's definitely not supposed to be there. Times 3. Okay, so let's get my red pen out. Let's circle things that match. So my 2's match, my 3's don't, so it's going to stay inside my square root symbol. So x minus 3 equals plus or minus 2 radical 3. Okay, then get x by itself. I'm going to add 3 both sides. And please don't turn that into a 5. When kids make a mistake, they put that as 5 eventually, but that's not correct. These guys are not like terms, so please don't do that. So x equals 3 plus or minus 2 square root 3. And there you go. That problem's done. Okay, I think this is the last problem. We're almost there. So come on, pen, cooperate. Don't lag on me. Don't draw extra lines that it's not supposed to be there. And we can get this done. So this one, we have 1/3 in front of our x squared this time. So that's going to cause us to do something a little different. We're not going to divide this time like we did the previous couple of problems. Okay, we're going to do something a little different. So having a fraction, is kind of like this. I'll kind of write it on the side here. So 1/3 x squared is kind of like this, x squared over 3. Yeah, so 1/3 x squared is the exact same thing as x squared over 3. And once you understand that, how to fix this issue might be a little clearer. We're not going to divide, we're going to multiply by 3 this time to everybody. And when I multiply by 3, it's going to make the fraction cancel out. Yeah, because it's going to basically be 3 over 3, which is eventually 1. Yeah, because the 3 times 1 is 3, and the 3 on the bottom is going to be 3 over 3. So 3 over 3 is a fraction, makes 1. Okay, so we're going to get x squared minus 6x plus 15. Okay, I know it looks like a negative 3 that I'm multiplying by, so please don't mind the extra line that the computer drew. It's kind of lagging out. It's kind of having its own thing, right? So just be careful. Okay, so now I can officially start complete the square. I'm going to cut negative 6 in half. Then I'm going to square it. Oh yeah, my pen is getting really sloppy. Sorry about that, people. Again, I get 9. So 9 should be sitting right next to the negative 6, not 15. So you need to politely tell 15 to get out of the way. Politely now, that's the key word. And then we're going to get x squared minus 6x equals negative 15. And then now we have space for the 9 to slide right there. Slide right there in that spot. So 9 can go right there. And I'm going to save some space. I'm going to write just 1 parentheses squared and x minus 3, because negative 3 makes 9 when I multiply. Negative 3 makes negative 6 when I add. And then equals negative 6 on the right side. Okay, so we want to make this negative 6 go to the other side, because then I have, well, like I said the previous 2 columns, okay, I'll have what looks like vertex form, so that's going to signal the end of this process. But this is not vertex form for this problem, so that's why I'm not going to write the words vertex form right next to this line right here, because this is not vertex form for my original problem. Okay? But as far as ending the complete the square process, this is the ending of it. Okay, so I hand the baton off to the reverse PEMDAS crew, and they do its thing. So x minus 3 squared. Okay, it's kind of lagging again. Sorry about the pen. So they hand the baton off, and we start solving for x. So let's get rid of the 6. So we get x minus 3 squared equals negative 6. Then I square root both sides. And we put a plus, we have a negative sign inside our square root symbol, so that's going to introduce an imaginary number to my answer. So just keep that in mind. So x minus 3, left side, equals plus or minus I, because that's my negative sign, right? And 2 times 3. Okay, let me fix that second I, because when I tried to make the dot, it didn't want to cooperate. It just connected everything together. And now it doesn't want to erase. Okay, erase now, but it erases too much. Oh, that's great. Okay, come on, this is the last problem. Cooperate, please. Don't mess it up right at the end. Okay, all right, so circle things that match. So I can circle the I's. I can't circle the 2 and the 3 because they don't match. So x minus 3 equals plus and minus I root 6. So you put the numbers back together again if they don't match. Okay? Then we're almost there. We're almost there. Come on. You can do this, pen. So plus 3 both sides. So we get x equals 3 plus or minus I root 6. And there's your answer. Yes, we made it. Okay, all right. Good luck with this section, especially the last couple of problems where you have numbers in front of the x squared that you got to get rid of. Okay, just try your best. It'll be tricky at first. I mean, it's either going to be multiplied by something or divide by something. It's one of those two things. Yeah. So just try stuff out, and if you make a mistake, big deal. It's only homework, right? This homework is where you learn anyway, right? But yeah, good luck, and I'll see you in class. Bye-bye.